Hey and welcome. Today we will solve missing number interview question. Let's get into it. Here's the first example. We have an array with lengths of 3, so we are expecting sequence of numbers from 0 to 3, but number 2 is not presented, and that is the answer for us to return. Second example, we have an array with lengths of 2, so we are expecting 0, 1, 2, but there are only 1 and 0, so we might return 2 as missing number. And last example, we have an array with 9 elements in it, so it is representing the sequence of numbers from 0 to 9, but number 8 is missing in the sequence here, so we will return it as a result. Let's see how we are going to solve this problem. The first solution that comes into mind is just simple sort. If we sort this array and we start to iterate through it, it will be obvious that which number is missing, because at some point we will be jumping 2 steps instead of 1 as usual. But as you might know, sorting has O of n log n time complexity, and we can do better than that, so no. Second solution could be a bit exciting to explore. Here is the last example we saw. As question says, the sequence of numbers presented in the given array is in range of 0 up to the length of array. So the length is 9 here. Then this array represents the numbers of sequence starting from 0 to 9. We might consider just iterating over that range, then check for every value to see if that specific value is represented in the array. And as soon as we see we don't have a number, we return it. And at this step, everything that comes after does not matter for us anymore, since we already found what's missing. And we are guaranteed that only one number is missing. You may get a bit of brute forcing vibe here up to the length of given array, and that is true. We are doing that, but the lookup for checking is a bit problematic for us, since we might do a search over entire array for each number. In such cases, we will convert the given array elements into a hash set, and yes, it will take up O of n space, but in return we will trade off space complexity for faster lookup time, because set.has will give us O of 1 time complexity for lookup, and just like that we will dodge the quadratic time complexity here. With that being said, let's jump into the code to implement this solution. So here we are in Leetcode. For hash set solution, first we need to create a set for our lookup process that we discussed. Then a simple iteration over nums and adding them one by one to the set. Now we will do a second iteration over length of array, because that is the range from start to end of the presented sequence. Then if a number does not exist in a set, that is what we are looking for, and we need to return it. At the end, we should return -1 just for not returning undefined by default. By the way, we have the guarantee on the problem about definitely there will be one missing number in the sequence, but we are doing it just for the sake of completeness. Now, if I run this, test cases are passing, and if I submit, we are in a good shape here. Now let's jump into the slides for more better solution. Okay, seems like we will have O of 2n time with O of n space complexity by our previous solution. I mean, the runtime of function is going to be a bit more since we are doing 2 iterations over the array. That is fine for now, but how we can skip the space complexity? To answer that question, we will rely on a more optimized solution with XOR or exclusive OR operator. What XOR does is if we XOR 2 numbers, each ones in their binary representation will be kept if and only if either of those numbers is 1 in that location, not both. If both are 1, the result will be 0. So the final result of XORing will be 2 in this case. You may ask how this could help us. Think about XORing all values in that array with its index number. Here we have the first example. Now let's convert these numbers into their binary representation just for the sake of showing you what's going to happen here. We know the length of the array represents the sequence length, so we can take it in our advantage and argue that all numbers will match with their index counterparts, except the one that is missing. So you might guess, okay, if we XOR all of them together, the similar numbers from values and index perspective will cancel out each other because they will have ones in the same binary locations. Then what is going to be left? We will hit 2 scenarios in that case. Either the missing number is the last number in the sequence, like this example here, or it will be in any position before last element. So for both of these solutions, we need to XOR all numbers in addition to XORing the length of the array with them. Because in first case, while all of those numbers are canceling out each other, the length of the array will stand out. And in second scenario, the missing number will stand out in between while again the other numbers canceling out each other. And that is the optimization that I was speaking of. With that being clarified, let's jump into the code to implement this solution. Here again, we are in Leetcode. First, we need to initialize a variable which initially holds the length of the given array. Then, a simple iteration over the length of the array. Again, because the represented sequence cannot be bigger than the array length as problem says. Now here, within this loop, we will kick off the XORing process by doing an XOR on index and the value in each iteration, and reassigning it back to the missing variable that we initiated at the beginning, while XORing to that as well. Here is where we involve the length of the array, the same missing variable, into the process of XORing in the very first iteration, and from thereafter it will be processed along the way. And finally, we know that what is left from result of XORing process, exactly the missing number that we are looking for. So we will return it. Now if I run this, tests are passing, and if I submit, we are in a good shape here. Now let's jump into the slides for time and space complexity analysis. So the time complexity will be O of 2n for hash set solution, which will eventually consider that O of n, and it will be O of n for XOR solution. And the space complexity will be O of n for hash set and O of 1 for XOR solution. So that was it for this video. Thanks for watching, and please leave a like, comment, and subscribe to the channel. I will put a few more links about different playlists in the description for you to check it out. And finally, hope you enjoyed this video and stay tuned for the next one.